artificial intelligence.
Hello, everyone. It's a pleasure to be here. That was a great panel before. Could you actually give it up one more time for that panel? Thank you. So, as mentioned, I'm Samuel George White. I'm a PhD researcher at Imperial College London, and my research area is artificial intelligence and neuroscience. So today, I'm just going to be speaking briefly about some of the research I do on a day-to-day and how I think that is going to impact the future of technology, specifically AI. So my research is focused on advancing human-machine interface systems. What these are systems that take the current abilities of humans and find ways of augmenting them so we can perform better tasks, faster, stronger, and easier. So these are a few of the ways that we can augment systems. We have power augmentation, which allows us to do tasks which require more strength. We have workspace augmentation, which allows us to be more technical in certain fields like medicine. We have precision augmentation that can help with people who have loss of function in their arms to perform more detailed tasks. And then finally, we have degrees of freedom augmentation, which is the main focus area. It allows us to control more aspects of space than we currently have available with our normal bodies. Right. So a few of the applications where these systems can be used. Top left image, we have it being used to essentially advance medical interfacing, so the use of robots, but robots that can actually be controlled directly by the doctor. Then bottom left, we have an example of someone playing a piano. Imagine how great music would be if you could play with 3 hands instead of just 2. Bottom right, we have someone who would be in a wheelchair with the loss of mobility in their arms, enabling them to use robotic systems to, for example, pour themselves a drink and do their normal daily activity lives. And lastly, we have systems that, if you imagine how often we all use our phones, you can simply think and signals can be pushed down to your arms, to your muscle groups, and they can actually be used to control electrical devices. So typically, as researchers, as engineers, we don't like to stop. Curiosity never ceases for us. The eventual advancements of all the technologies I previously mentioned lead to fields such as bionics, which is where we have robotic systems which are integrated directly with the human body. Can I get a show of hands? Has anybody seen RoboCop, the film? Yeah, that's where we're headed. So great. If this video plays, it's just going to show the current level of where we've achieved with bionic systems. So this is a lady who's lost both hands and partial parts of her wrist, and she's able to use these bionic systems, which have advanced to a point where now she's able to actually hold and pour herself a glass of water, meaning she can control her hand to the point she can actually clench the bottle, lift it, tilt it, and then also drink herself. Very amazing. And then, if I could skip ahead to the next slide. Yeah. So specifically on a day-to-day, this is what my research is focused on. It's essentially when we think of performing different actions, signals get sent from our brain, through our spine, along our nerves, and into our muscle groups. I'm looking at how we can manipulate those same signals that originated in the brain to control electronic devices. Essentially, you can think of a certain movement, and you're able to control something external. How this works is using AI systems to essentially take the signals that are from your brain and spinal cord, which get fed down finally to your muscle groups, look at the associated patterns, doing a lot of signal processing work to find out, okay, if we pick up this signal at the muscle, what essentially was the initial thought that generated it, and using artificial intelligence systems to decode it, to work backwards, so that instead of us just thinking it, we can actually, when those signals are picked up, use them to control robotic devices. So the main artificial intelligence or neural network systems I use or I train are classifier networks. So I've just got the architecture of one classifier network I've used that has actually given pretty good results for this research. So these are the classes from a classifier network. What we want to do is predict which class, if I input a muscle signal or an EMG signal, I want my classifier network to know, okay, the person thought to flex their arm, or the person thought to extend their arm. Can our AI system grow or learn enough to be good enough to actually distinguish between the two? And we have various different classes. I want you to pay attention mainly to class 5, which is movement after an error. Essentially what that is when we think or when we're using a robotic system, there's a time where between me flexing my arm and extending my arm, I've stopped movement, but my brain is actually continually sending signals down to say, stop moving, we're going to change the direction in which we're moving in. Trying to decode those intricate signals is going to allow us to pave ways for things like cancellation of movements. Somebody who doesn't actually need to move their arm, but can think about cancelling any movement, and that same signal can be used to control robotic devices. So robotics controlled via thought. These are from my AI network, using it in real time, some of the results I achieved. This is an essential overview of how the model performed in detecting different classes. We have the baseline class, flexion, extension, and more classes. This is a more detailed view. And I just want to highlight the strength of the model. It actually performed a lot better than even my supervisor thought, so a round of applause for me. Thank you. It was actually able to accurately classify the different signals in a much more accurate and generalized view. The typical problem we have with AI systems when it comes to training them is it just memorizes all the data you input instead of actually learning what each signal represents. But I got great results when it came to generalizing. Cool. Just to summarize, discussing briefly on the preliminary results, it just shows that there's actually potential and future evidence that we can control robotic systems just through thought. And the findings from this let us know that there's a pathway for different applications that can be in medicine, where a doctor can simply think of doing a movement and it can accurately train a robot to perform a specific movement, which links to more degrees of freedom and more accurate surgeries, for example. My current focus for the remainder of my PhD is focusing on refining these AI models and then going on to train external robotic devices. So one day in the future, bionics aren't going to be a strange concept and are actually going to be used to benefit the lives of many people, disabled people, and also people in various professions such as medicine. Thank you.